In this last presentation, we're going to take a look at centripetal force. Centripetal force is the force required to keep an object in circular motion. If you could think about examples of things that you know move in a circular motion that's uniform, say like the orbit of Earth on the Sun, there's always a force, in this case the force of gravity, that's keeping that object moving in its circular motion. If you've ever played tetherball, you've experienced this as well. In tetherball, there's a rope that's attached between the ball and the pole. The rope itself is providing a force of tension that's keeping the ball moving in a circular motion. So we've already established how to determine the circular speed. We've already talked about what centripetal acceleration, but we know from dynamics that for every acceleration, there must be a corresponding force. So that centripetal acceleration we're experiencing also has a corresponding centripetal force that's looking at that. And this is that force that's required to keep it moving in a circular motion. Centripetal always means center seeking. So centripetal force literally means force pointed towards the center of a circle. And the units of force, just like all the other units of force, is newtons. The equation for centripetal force is force centripetal is equal to mass times acceleration. So it's still another iteration of Newton's second law where we have F equals ma. So force equals mass times acceleration. Just for centripetal force, you need centripetal acceleration. And we also know that centripetal acceleration is velocity squared divided by radius. So we can relate centripetal force to velocities and radiuses of things that are moving in a circle. Let's go ahead and do an example of that. And in this next example, we have a 1,000-kilogram car that's moving at a constant speed of 20 meters per second around a horizontal circular track. The diameter of the track is 100 meters. We want to figure out what the magnitude of the car's centripetal acceleration is, and then what the centripetal force of the car is as well. So let's start with centripetal acceleration. We know that acceleration is velocity squared divided by radius. In this case, the car is moving at 20 meters per second around the circle. So there's our velocity. And it has a diameter of 100 meters, which means it has a radius of 50 meters. If we take that 20 squared divided by 50, we end up with 8 meters per second of centripetal acceleration. Now that we have our centripetal acceleration, it's just one step further to get it to force. We know that F equals ma, so force is equal to mass times acceleration. Our mass here is 1,000 kilograms, and the centripetal acceleration is 8 meters per second squared. And that yields us a centripetal force of 8,000 newtons.